So now that we've created this environment and the creature model and added some procedural animation to the creature, let's start making those creatures fly around the scene. So you can turn off the display on this creature, and let's dive inside here. Let's show all objects, and we're going to base these flight paths on a basic circle to start with. So let's make the circle pretty big because this environment scale is quite large. And I'm going to leave the circle at the origin and just use a couple transform stops to move it into place. So let's display the transform and move that over and up in the air a bit. Back on the circle, let's change the orientation to the ZX plane. And we'll set this to be a polygon. And the archetype will be open so that it just gives us these poly lines around the edge. And we'll give this some more divisions. Now that we have this basic path here, let's start adding some noise to that. And this noise will, default to the color. So let's change that to the position P and set that to be 0 centered. And because we're at a large scale here, let's go high amplitude, like try value of 100, which looks a bit crazy now, but that's partly because our element size is still quite small. So let's turn that up, that's 100, let's try going even higher, of 150, and this path is still going to be far too noisy. And we can smooth this out quite a bit by going into the fractal section of the noise settings and turning these max octaves down. So by default, it's layering, a few different octaves of noise. And we can turn this right down to 0 to only get one, basic octave of noise without the extra detail. And you can finesse this as much as you want. Perhaps we don't want the X and Z amounts of distortion to be quite as extreme. So if you go up to your amplitude here, click on this XYZ button, and you can change the amplitude scale for each axis. So I'll try turning it down to 0.5 on X and Z so that most of that amplitude is happening in the y-axis there. And after applying this noise to these curves, sometimes it can create some uneven spacing, which can result in speed variations so that the creature seems to go faster through areas where the points are spaced out more, and it'll appear to go slower where the points are closer together. So you can drop in a resample to make sure that your point distribution is nice and even. It's a pretty subtle difference, but if we bypass that, it's kind of hard to see, but it does make sure that all of our points are spaced out evenly when we resample this with a length of 3. And then to create a second flight path, you can of course just do the same exact thing. We'll use the same circle, and we'll just transform this one to a slightly different position. And then on the noise, we can modify this a little bit further by changing the offset. So let's go on that noise down to the offset here. And we're at a large scale, so I'll just use a pretty big offset of 1000 to give this a bit of a different shape. And we can tweak these some more once we start getting the creatures flying along this, and once we actually see things in context. And of course we'll do the same resample that we did to the other circle. So I'll just create a reference copy of this resample so that we're always resampling both of these curves to the same level of detail. And now to get the creatures flying on these paths, let's bring in that basic animation that we set up. So drop in an object merge. That'll point to object, creature, out basic anim. And then we can use a path deform to animate that creature along these flight paths. So the creature can go in the first input. one of the paths into the second, and let's display that as well as the current path we're using. And this doesn't look right just yet. First of all, it's not actually moving, and you can see it's not facing the correct way, and it's not aligning with the path at all. Now, to fix some of the issues with the way this is getting path deformed by default, we can first modify the capture of this creature, which essentially defines how this creature is aligned relative to the path. So go to Capture and Align and change the forward direction to X, because that's the direction the original creature model is facing. And now that's correctly deforming along the curve here. You can also reverse the curve with this checkbox here if you want it to fly the opposite direction. And underneath this capture here, this is a little bit of a tricky option because it's not necessarily obvious right away that this default is problematic. But if we, scroll through our timeline here, you can see the creature's kind of wobbling around on that path in a sort of unstable way, because when we're using this relative to bounding box option, the bounding box is actually changing a little bit with this animated input. Because these tentacles are moving around, then the bounding box is constantly changing. And it's only a subtle change here because our procedural animation isn't throwing these tentacles very, very wide, and it's not making the bounding box size change a whole lot. And when we do the vellum sim, that's going to cause a more extreme change in the bounding box for the creature. So this sort of unstable wobbling behavior will probably get worse with the vellum version. So we can fix this by changing the GeoCapture origin to custom, and you can just leave this alone. That origin value is just fine. And now, if we scroll through the timeline, you can see that we no longer have that sort of unstable wobble in the way this is captured and aligned on the curve. And now to get the creature, flying along this curve here, we can go back to the Map and Deform tab, and we're going to use the Curve U position to get it to fly through space. And you'll notice that as this Curve U position increases, it's actually flying backwards, and the easiest fix for this is to just rotate the creature itself. So let's just drop in a transform SOP, put that on the incoming animation, and we can rotate that 180 degrees. So now the creature will be flying forwards instead of backwards. And you can also change the overall size of the creature at this point as well. In my case, I scaled it down a little bit to 0.7. And you can see that after we've rotated this creature, it no longer correctly follows the curve here. So let me go to a curve position where that's a little bit more apparent. Like once we get up here, you can see now it's just rigidly following this curve and it's not deforming with it. And one fix that we can make for that is back on the Capture and Align here. If you scroll down to this Capture Before Start Position option, you can toggle that on, and that will fix this issue. And then to drive this Curve U position, rather than just animating this, let's use an expression based on the current frame. So type @frame divided by a number that's going to determine the speed of the animation. Let's try 500 at first. And if we zoom out, let's see what this looks like. See creatures flying around like so. And actually, to illustrate the problem with this, I'm going to go with a different division here. Let's try dividing the frame number by 50 instead. And as we scroll through here, once this gets to frame 50, then it's just going to send that creature shooting off into space. It doesn't, wrap that UV value around to continue its cycle along the curve. And the point at which this is shooting off is actually going to be, where the curve starts and ends. If you display the points here, the point numbers, you can see at this point, this is kind of the start and end point of the curve there. And that's the point where, the creature isn't going to successfully wrap around, just kind of shoots off into space. So we can fix that by taking this curve view position, saying %1. This is going to give us the remainder of this division operation when divided by 1. So essentially, if frame divided by 50 evaluates to a number like 100.3, this will just return the 0.3 portion of that. So when you add that on there, you can see now it's keeping this computed curve view position within the value between 0 and 1. So this will cycle nicely forever and ever. And this is a little bit fast for what I wanted to do with the scene, so I found a speed of 300 seemed to work pretty well. And it's a little bit slow to calculate this on the fly, so you'll probably need to do a flipbook to see how fast this is really moving. So let's run that so that we can dial in the speed properly. Now this is what the creature looks like with our current speed on that curve view position. And it looks pretty cool, but I'd like to slow it down quite a bit. So instead of dividing frame number by 300, I'm going to set that to 600, which will slow it down by 50%. And I'm going to copy this path deform, paste that in here, and then connect this copy to the other curve that we've made. And let's label these squids. I'll call this squid 1 and squid 2. And then we can merge these together because we'll want to tweak them with both of them visible so that we can make sure the animations kind of go well with each other. And you can see right away, as soon as we merge both of these creatures like this, it kind of looks like they're both right next to each other and they're kind of mimicking each other a bit too much. So you could try reversing the curve on one of them, or we could go back to our transform stops on the circle here, and we could rotate these circles in Y. So I'll display both of the circles as well, just for clarity. I'll call this flight paths, and let's template display that. So if we rotate one of these, let's try minus 90 degrees, that makes these animations much more different from each other. They're not kind of visually lining up quite as much. And of course you can, tweak this however you'd like to work nicely with the camera framing. Now, in addition to these two creatures that are flying around here, I also want one of these creatures to emerge from the ground, and that's going to be pretty important for when we do the destruction later. We want to create a pretty cool destruction event with this creature bursting up out of the ground there. So once again, I'll start by using this same circle, and I'll just transform that into position. And in order to get one end of this circle sticking down into the ground, I'm going to use a soft transform. And in the group here, I'll just put in a 0 to grab the very first point. I'll translate that down 100 units. Let's display that soft transform. So just this one endpoint is getting pulled down into the ground there. And then of course you can increase the soft radius to round this out a bit. Although you don't have to just rely on this soft transform to round that out. We can also do some smoothing. So I'll just use our resample with the same resolution that we used for the other circles. So I'll just copy that resample here. Because right now, without resampling this, you can see that we have all of these points along the top, but there are only a couple points along this large stretch here. So let's resample this to a more uniform point distribution. Then we can use a smooth SOP to kind of round this out a bit. So when we display that, we get a little bit of smoothing right away, but I want a whole lot more smoothing than this. So let's turn this up to 100. But on the smooth SOP, this filter quality tries to preserve some of your details, and oftentimes when we're smoothing things with this SOP here, we don't really want the details to be preserved. So when you turn the filter quality down to 1, then that will round things out a whole lot more at the cost of some of the original shape. But that's totally fine because we don't really care about losing the original shape. And this gives us a much nicer curve to work with. And once again, we'll use the same attribute noise as before, although in this case I'm going to turn down the amplitude a bit. And you can do as much procedural modeling as you want here. In my case, I just, remodeled this path a little bit. I didn't really like this, this big dip up there. So I just kind of pulled that down with the soft transform, added a little bit more noise and smoothed it out. And you can go as crazy as you want finessing these curves to your liking. And then after all of this procedural modeling, let's make sure we have some good UVs on here. Just drop in a new UV texture SOP, set this to rows and columns for an even 0 to 1 U value along the length of this. And then we can copy one of our path deforms from earlier, paste this down here, and connect the new curve to the second input of this path deform. And you can see that right now the creature is flying into the ground. It's not emerging from the ground. So we just need to reverse this curve, go to that path deform, capture and align, and uncheck the reverse. So if we go back in time here and start scrolling ahead, you can see once we get to around frame 30 or so, this creature is starting to emerge from the ground, which will make for a very cool destruction event. Now you might want to tweak the timing of where this creature emerges from the ground here, in which case I think the easiest way to do that is with a time shift after the path deform. So just drop in a time shift, and I have a preset saved for a time offset here, which I highly recommend you make. And to create that preset, and let me undo that and just create that preset from scratch. If you go to Edit Parameter Interface, let's drag a new float parameter from the left to the right here. The label, we'll call that offset, and set the name as well. And the range I'm going to set to 0 to 1. Actually, we'll make that -1 to 1. And I'm not going to lock that so that you can set it above or below that range. So hit accept, then right click the offset, copy that parameter, then go to this frame expression here. And instead of $f, let's change that to $ff. So it's a float frame and not an integer. And I'll say plus, right click, and paste relative references. And let's also turn off integer frames so that we can use this to check subframes if we want to. And then to save that preset, just go to the gear here, save that as time offset or whatever you want to call it. Now if we display that, we can, time nudge this around. If we want to delay the reveal of this creature, we can set the offset to -10 frames. And it would be a good idea to clamp this to frame 1 just to be safe. So now as we scroll through our timeline a little bit, it takes 10 frames longer before this creature emerges from the ground. So you can feel free to tweak the timing of things that way. So now we're all done animating these creatures. Let's merge them all together. Drop in a merge SOP, and let's connect these two paths and the one that's going to drive our destruction event. And just for display purposes, I like making these darker right now so they kind of stand out from the rest of the environment. And you can just use a color SOP, of course. And I'll change this to HSV and just turn down the V. And this is totally fine, but this color is being applied to all of the 261,000 points on these creatures, and I think that's probably pretty fast for Houdini to just add that color attribute. But just in case this is any more efficient, one thing that I do sometimes is I will just pack these deforming creatures. So these three creatures are now combined into one packed object here. And now when we apply that color, this color attribute only needs to be applied to one singular point instead of 260,000. I don't really know if this is any more efficient. I haven't actually tested it, but it seems like it might be, so it's a thing that I do. So now finally, I'll set a null for these out deforming creatures, and let's do another flipbook to see how this looks. And now our flipbook is done, and this is what it looks like, and it's looking pretty good. The two circling squids here and here are looking like they're at a pretty decent speed, but the one that's coming out of the ground, I'd like to animate quite a bit faster. So it's a pretty quick change. If we go back to the path deform, just for that one creature, we can just change this curve view position expression from 600 to 300. So you can see that creature's position will jump from there to a bit further ahead. And I didn't bother to cache this out. You could cache out this deforming geometry if you want, but because it only took a minute and a half to flipbook this, it's not terribly heavy, so I didn't bother caching it myself. And there is some overhead involved with reading back these slightly heavy caches from disk. So it's kind of up to you in a scenario like this if you want to cache it or not. In a film production pipeline, I certainly would cache it just to have a safe version saved and deliverable. But for this personal project, I'm not bothering to cache it. So before running a new flipbook, I'll just hit this little X to disconnect this mplay session and save that old version in case we want to refer back to it. And then we can run a new flipbook with this updated creature speed. So now we have our new flipbook with that third creature flying a bit faster. And yeah, I'm pretty happy with how this is looking. And now we can move on to setting up a camera and some lighting and rendering for this scene.